Hello, Namaste, Mr. Bossert here. All right, so we're talking about rational exponents. And rational, as we know from chapter 4, means fractions. So these are exponents that may be fractions. So the first couple of things, we've talked about this a couple times. The 1/2 power is the square root. All right, so 25 to the 1/2 is the same as the square root of 25, which would be 5. And so the 1/3 power is the same thing as what we would call the cube root. All right, and the cube root is written like this: the radical sign with the index of 3. All right, that's this right here. Index of 3 is talking about the cube root. In other words, what to the 3rd power is 8? And obviously that's 2. So we would say that the cube root of 8 is 2 because 2 to the 3rd power is equal to 8. So again, if I say cube root and cubing are their inverses of one another. And so the inverse of 3 would be 1/3, and that's why you can also write the cube root as that. So we should probably be familiar with some of these basic cubes and even 4th powers. So when I see 8, I am thinking of 2 to the 3rd. When I see 27, I am thinking of 3 to the 3rd. 4 to the 3rd, I should know, is 64. 5 to the 3rd, 125. I think that's reasonable for us to know. 6 to the 3rd, 216, maybe stretching it a little bit. But then 2 to the 4th power, 16. 2 to the 5th, you should probably also know, is 32. 3 to the 4th, 4 to the 4th. So those would be valuable powers for you to know in addition to your squares. So again, the square root of 5 is equal to 5 to the 1/2 power. Cube root of 5 is equal to 5 to the 1/3 power. And, you know, my power rules from chapter 4 work here. So if I have 5 to the 1/3 times 5 to the 2/3, multiplying like bases means I can add the exponents. And so this is 5 to the 1/3 plus 2/3 is 5 to the 1st. All right, or 5. And my division, if I'm dividing like bases, 6 to the 4/3, 5 by 6 to the 1/3, just because they're rational exponents doesn't mean the rules don't apply. So I would subtract the exponents here and get 6 to the 3/3, which is 6 to the 1, or 6. So my power rules apply just because they're fractions or rational, it doesn't matter. 2 to the 5th is 32, and so 32 to the 1/5 power, or the 5th root of 32, would be 2. And so we could write it like this. With the index of 5 in the radical would be the 5th root of 32, and so that would equal 2. Okay, so what if the fraction has a numerator, the power that's a fraction has a numerator that is not 1? Right? Or something trickier like this, 16 to the 1.5 power. Well, I would probably do this, change this to 16 to the 1.5 is 3/2. And then what this is going to mean is I'm going to take 16 and I'm going to make it to the 1/2 to the 3rd. Because power to a power means I can multiply, right? 3/2 is the same as 1/2 times 3. So the 16 to the 1/2 would be 4, and then to the 3rd power gives me 64. So 16 to the 1.5 power is 64. All right, so again, this works because, move this up here. 2 to the 2nd to the 3rd power to a power means I can multiply the exponents. So the exact opposite is going to be true with our rational exponents here. 8 to the 2/3 power. Method 1 in evaluating this is going to be splitting the rational exponent into 2. So one way to split it would be change the 2/3 to 2 times 1/3. So I could write it like this. And then take 8 to the 2nd to the 1/3, 8 to the 2nd, evaluate that as evaluate base with 1 exponent, so that would be 64. and then apply the other one. 64 to the 1/3 means the cube root of 64, which is 4. The other way to split it would be 2/3 split it into 1/3 times 2. And 1/3, or the cube root of 8, is 2, and 2 squared is 4. So either way, we would end up with 4 here. So this is one method, is to take the rational and split it into 2. Method 2 would be, I'm going to rewrite the base and cancel the exponent. So here, I took advantage of the fact that 8 is the same as 2 to the 3rd power, so I'm going to rewrite it as 2 to the 3rd to the 2/3. And then you'll notice that 2 to the 3rd to the 2/3, if I multiply the bases here, the 3's will cancel, and this will leave me with 2 to the 2nd, which is 4. So obviously same answer, another way. So if I think I can rewrite this base, a lot of times it will go nicely with the power and cancel out. In this case, it canceled out the 3's, left you with 2 to the 2nd power. So that would be another option. So let's take a look at 125 to the 2/3 and 64 to the 5/6 power. So I want you to either use method 1 or method 2. All right, I'm going to show both here in a second. So I'm going to pause this. I want you to pause. Try to see if you can use method 1 and method 2 to come up with answers. Okay, so you can see a couple examples of method 1 and method 2. Method 1, I took the 125 and I split the 2/3 power into 1/3 times 2. So the cube root of 125 is 5, because 5 to the 3rd. So this becomes 5 squared, or 25. The other option is to take the 125 and change it to 5 to the 3rd power. And when I multiply 3 times 2/3, I get 2. So 5 to the 2nd is 25. And I do the same thing here with 64. Change it to 2 to the 6th to the 5/6, which is 2 to the 5th, or 32. Or the 6th root of 64, it would be 2. So 2 to the 5th is 32. Either way is pretty good. And again, you see that it is really important for you to understand and know some of those powers, rather than, more than just squares. All right. See if you can get the answers to these. You can pause it. I would change this to 4 to the 3rd to the 2/3. And so that is 16. 16, the square root of 16 is 4 to the 5th. Yikes. It's the same as 2 to the 10th, so that's 1024. We'll just guess. Sorry, Luke. All right. Now, cube root of negatives. Now, we could not do the square root, right? I can't do the square root of -4. That's no real answer. And so -4 to the 1/2 power is no real answer. However, if I had -4 to the 1/2 like this actually is -2, because here the 1/2 of the square root is only controlling the 4, not the negative. So be careful where the parentheses are. This is really tricky. This would be -2. This would be one you could do. Going up here, the cube root, you can do the cube root of a negative, because this is going to end up being -2. -2 times -2 times -2 would be -8. So -2 to the 3rd power is -8. That means the cube root of -8 is -2. So that one's okay. What if the exponent's negative? Well, negative exponent, remember, doesn't mean negative. It means reciprocal. So again, I would probably separate this into 2 to the 3rd, which is 8, to the -2/3 power. And then when I go ahead and multiply the bases, that gives me 2 to the -2 power, which is 1 over 2 to the 2nd, which is 1/4. So a lot of exponent rules and rational exponents going on here together. There's is what I would say here. So again, 2 to the third is the same as 8, so I change this to 8, which is 2 to the third to the negative 2/3. When I multiply, the 3's canceled. 2 to the negative 2 means 1 over 2 squared, which is 1/4. And again, remember, negative exponent doesn't mean negative. It means reciprocal, right? 2 to the third is 8. 2 to the negative third is 1/8. This is a similar chart that we saw in chapter 4. I want you to do these last couple of examples and come back when you have answers. All right, so 1/5 and 1/64. Again, negative exponent, I know it's going to be a reciprocal deal there. Last one, this is going to be 1 over 2 to the 4th, which is going to be 1/16. We'll do some more examples about those. All right, thank you very much for listening. Namaste.